Introduce this lesson with a guessing game. Have one person walk past a magnet that has been suspended from a place that is easily seen. Have 3 or 4 other people do the same thing. One of these people should have a strong magnet hidden, and another person should have a weak magnet. The student should try to identify who has the strong magnet and who has the weak magnet, and who does not have a magnet on them at all. Emphasize that even though the magnetic field around a magnet is invisible, it can still exert a force on certain objects. Both the strength of the magnet and the distance apart determine its effects on magnetic materials. Students will need to find holders for the magnets. The outer part of a matchbox will work well, but be sure to use tape to keep the magnets from sliding out. A small Ziploc bag will hold it also. A piece of string can be pushed through or taped to the string and tied to a stationary object so that the magnet can swing freely. The student should examine the following ways in which a handheld magnet can interact with the hanging magnet. Bring the south end toward the south end of the hanging magnet. Bring the north end toward the north end of the hanging magnet. Bring the north end towards the south end, and bring the south end towards the north end. When the students have caused the hanging magnet to stop moving, they should give it a slight spin and allow it to completely stop on its own. Record the way the magnet points when it is stationary. Now have the student hold a compass in front of them away from any of the magnets. Have them turn the compass around once and wait for the needle to stop moving. They should compare the direction in which the needle is pointing to the direction in which the hanging magnet has turned. This investigation will demonstrate the effects of a magnet's strength and the distance between a magnet and a magnetic material, such as iron or steel. Students will lay a ruler on the table and place a pin at the end of the ruler. They will place a magnet at the opposite end and slowly slide it towards the pin, recording the distance between them when the pin first moves. They will repeat the activity using a different magnet. Students will need 2 magnets to do the following investigations. Have them predict what will happen in each case. Place the north end of one magnet near the center of the other magnet. Try to push 2 like poles together with their hands. Have a north pole and a south pole close together but with a small space between them.